Okay, here we go. Question 13 of this chapter 8 mixed exercise. So, binomial expansion of 2k plus x to the power n. Okay, where k is a constant, n is a constant, n is a positive integer even. The coefficient of x squared and x, so x squared and x cubed coefficients are equal. Prove that n equals 6k plus 2. So I suppose we better have a look to see what the coefficients of these are. So we are going to have in here, we are going to have n0, n1 for x to the power of 1, n2 for the squared, and n3 for the x cubed. That's going to be multiplied by 2k to the power n, and then 2k to the power n minus 1, and then 2k n minus 2, and 2k n minus 3. Getting it all mixed up there. So it's just going up minus 1, 2, 3. So it's just descending in powers there. And then that is going to be multiplied by x to the power 0, x to the power 1, x to the power 2, and x to the power 3. So basically, the coefficients, which will be all of this bit here, this n2, 2k, n minus 2, and this bit n3, 2k, n to the minus 3, are equal. So we can say that n over 2, 2k to the power n minus 2 is equal to n3, which is the NCR bit. Don't know why I've got division in that. 2k n to the minus 3. Okay, so first things first, let's get this NCR bit out of the way. So if we remember that we have something like, if we have 5 factorial, it's 5 times 4 times 3 times 2 times 1, and underneath it we have 2 factorial, 2 times 1, times by 5 minus the R number, which is 5 minus 2, which is 3, so we have 3 times 2 times 1. Okay, so on this one, we've got n times n minus 1, so we've got n times n minus 1 times by, divided by 2, 2k n minus 2, and on this one it's going to be times 3, and it's going to be times 2, so the 2 there, 6, so it's going to be over 6, and it's going to be n times n minus 1 times n minus 2. Okay, as we go down in the descending powers there. Okay, still with the 2k n minus 3. Okay, with all of that in, now what we've got to do is try and sort this out to see that n equals 6k plus 2, hopefully. Okay, so what do we have? Let's multiply that out. So we get n squared minus n over 2 times 2k n minus 2 equals where's that one going then? n squared minus 3n. So what's that first bit come into? It becomes n squared minus 3n plus 2. Multiply all of that by n, gives us n cubed minus 3n squared plus 2n all over 6, 2k to the n minus 3. Remembering that 2 is also to the n minus 2. Okay then, multiply by 2, multiply by 6. Let's get this all onto a common footing. So we end up with 6n squared minus 6n, and that all needs to be multiplied by 2k, which is n minus 2. 2 times n cubed minus 3. Am I multiplying that one out? Might as well. Two n cubed, 6n squared plus 4, and all of that is multiplying by the 2k n minus 3. All right. Let's see what we can do with all of that. So I've got 2k n minus 3 there. I feel like that's going to cancel out for me. I feel like we want this all to the power n or something, but we'll have a look at it. So I feel like I've got here 6n squared minus 6n, and that is multiplying 2k to the power n over 4k squared, and this bit here is equal to 2n cubed minus 6n squared plus 4n times 2k to the n over 8k cubed. Not entirely sure how that's helping me. I can take that out, I can take that out. That should just give me n minus 2. Okay, because this is all multiplied, let's go up here. Let's say that 8k cubed 6n squared minus 6n 2k to the n equals 4k squared, 4k squared, 2n cubed minus 6n squared plus 4n, 2k n. Okay, that's looking pretty good. So what can we do here? We can say that 2kn cancel. Okay, we can say that 6n squared minus n cancels into this, leaving n plus 2, because when we came back here, if I had it cancelled by the n's and the n minus 1, I would have been left with n minus 2. So not n plus 2, but n minus 2. Okay. So, and I'm going to get rid of the 4 and make that into a 2. So, what do we have now? We've got 2k cubed equals k squared n minus 2. Okay. The n squareds cancel, or not the n squared, the k squareds cancelled, leaving you just a k on this side. meaning we are left with 2k equals n minus 2, so that means 2k plus 2 equals n, which I don't think, plus 2. Did I lose a multiplier somewhere? Let's go back and check it, because it wanted n. Okay. Three times 2 is 6. Here we go. As I multiplied by the 6, I multiplied by the 2. I haven't accounted for that. Okay, so that gives me my extra 3, which would have left me with, so if it's the n squared there, I would have had 6 and 2. So I carried it down with a 6 and a 2. Give me a different colour for that. 6 and a 2. Basically, I've multiplied by the 6 and the 2, and I've then ignored it when I've cancelled this quickly with the n minus 2. So this was 6 times. So the 6 was on this side, so the 2 would cancel on that side, give me 3. 2 times 3 is 6k, so yeah, times 3, which then gives me 6, which gives me 6k plus 2. Yes. So 6k plus 2 equals n, as they wanted in the book. Okay, given that k is equal to 2 over 3, okay, so now they tell us that k equals 2 over 3, therefore 6 times 2/3 plus 2 equals n, meaning that n is 1248. Okay. Is that correct, or is it 6? I've forgotten. I had a feeling that was wrong. It's 6. Now that I've put it into the calculator, don't make the simple mistakes. Okay. So n is equal to 6. So part B, given that k is this, in ascending powers of x up to and including x cubed, give each coefficient as an exact fraction in its simplest form. Okay, so they want us to basically do this for the whole thing. Okay, so k is 2/3, so let's have a little look at it. We could use the answer from above, but I think it might just be easier to put it together and have a look at it. So we've got bracket 2 times 2/3, okay, plus x to the power of n, or 6 even, okay. 2 times 2/3 is 4/3, so we've got 4/3 plus x to the power of 6, and they want us to do the whole binomial expansion up to the powers of x to the power of 3. Okay, so 1, 3, 3, 1, 1, 4, 6, 4, 1, 1, 5, 10, 10, 5, 1, 1, 6. This is the line we want. 15, 20, 15, 6, and 1. Okay, so that's the line we want. So first lines, we've got 1, 6, that's the x, that's the x squared with the 15, and that's the x cubed at the 20. Okay, and we've got 4/3 to the power of 6, and then we've got 4/3 to the power of 5, 4/3 to the power of 4, 4/3 to the power of 3, and then we've got x to the power 0, x to the power 1, x to the power 2, x to the power 3. Okay, so 4 over 3 to the power 6 is, they want it to the exact fractions, so 4096 over 729. 4/3 to the power 5 is 1024 and 243 multiplied by 6 is equal to 2048 over 81 x. 4 to the power 4 divided by 3 to the power of 4 is 256 over 81 multiplied by 15 is 1280 over 27 x squared, and then 4 divided by 3 to the power 3, 64 over 27 multiplied by the 20, 1280 over 27, which of course we knew they were equal. They told us at the start of the question. Okay. And so you can write out the, given each coefficient in its exact fraction form. Well, there they are, the 4 coefficients. Okay, for 4 marks. All right. Next question. Question 14. Expand 2 plus x to the power of 6 as a binomial series in ascending powers, given each coefficient as an integer. Well, as it goes, I've just done a power of 6, so I know my NCR values are going to be 1, 6, 15, 20, 15, 6, 1. So I'm going to write them down straight away using the information from the last question. You could, of course, use the NCR button on the calculator to work them out if you didn't have them. Okay, so 1, 6, 15, 20, 15, 6, and 1. Okay, and now we're going to have, that's going to be times by 2 to the power 6, okay, and times 2 to the power 5, 2 to the power 4, 2 to the power 3, 2 to the power 2, 2 to the power 1, and 2 to the power 0. And then we're going to have x to the power 0, x to the power 1, x to the power 2, power 3, 4, x to the power 5, and x to the power 6. So as this comes out, 2 to the power 6, 2 to the power 6 is 64. So we have 64. 2 to the power 5 is 32 times 6, 192, 192x. 2 to the power 4 is 16 times 15, 240. Okay, 2 to the power 3, 8 times 20, 160. 4 times 15 for the 2 squares, 60. 2 times 6 is 12, x to the 5, and x to the 6 on its own. Okay. Now they want us to do part A, part B, and of course all of that would be added together. I suppose we should write it out, but I'm not going to here. By making a suitable substitution for x in your answer to part A, show that 2 plus the square root of 3 to the power of 6 minus 2 minus the square root of 3 to the power of 6 can be simplified as something to the power of 3, k to the power of 3, stating what k is. So just work this out. Okay. So we are going to have 64. So doing the 2 plus 3, we're going to have 64 plus 192 the square root of 3 plus 240. Now square root of 3 squared is going to be 3, so 240 times 3 is 720. Okay. Plus 160 times by 3 is 480 square root 3. This one's going to be 2 3s. 3 times 3 is 9. 60 times 9 is 540. Okay. And this one is going to be 9 times 12, 108 square root 3. And then this is going to be 3 times 3 times 3, which is 27. Okay, so with all of that in, we are then going to be doing a takeaway on a minus, well, 64, same thing, but this time we're using minus square root 3 into this, okay, because previous thing had been a plus x, okay, so minus square root of 3 going in this time, so we've still got 64. And then it's going to be minus 192 square root 3. And then it's going to be square root of 3 is 3, so that's a minus. So it's minus 720. Okay. This is going to be a minus square root of 3. No, minus and minus gives us a plus, doesn't it? Ooh. So yes, so that's just 720. My apologies, plus minus, yeah. Okay, this term will be a minus, which is going to be 160 times the 3, which is the 480. 480 square root of 3. And then we should be on a plus 540. And then a minus 108 square root 3. And then a minus, no, a plus 27. Okay, so just alternating down plus, minus, plus, minus, plus, minus, plus. There we go. Okay, and now we've got to change all the signs on those ones. Okay, so if we make this into a plus, this one becomes a minus, that's a plus, this one's a minus, plus, minus, plus, minus, when we get rid of those brackets. And now we can do a bit of cancelling, because the 64 and the minus 64 disappear. The plus 720 and the minus 720 disappear. The plus 540, minus 540, and then the plus 27 and the minus 27 all go. And then all of these are pluses, so we need to do 192 plus 480 plus the 108 plus, now it's just the same again, so instead of doing plus on all of them, 780 multiplied by 2 gives you 1560. 1560 root 3. So your K value is 1560. Okay, last one for this video, question 15. Okay, the coefficient in the x squared in the binomial where k is a positive constant is 2800. So we've got the coefficient of 2 plus kx to the 8, and the 2800 is for the, and that has a 2800x squared term. Okay, and so use algebra to calculate k. Okay, so we know that we are going to have 80, 81, 82. So we have 82 times 2 to the power, it was 8, it was 7, it was 6, and kx to the power 12012 squared. Okay, meaning that we have 8 to the 2, 8 NCR 2 gives you 28. 28 times 2 to the power 6, 64, times k squared x squared. So that means 28 times 64 is 1792. K squared equals 2800. Okay, cancelling off the x squareds. Okay, so k is equal to 2800 divided by 1792, 25 over 16, square root of, which is equal to 5 over 4. Very nice. Use your value of k to find the coefficient of x to the power 3 in the expansion. Okay, so if we know that, we can do 8, 3. We can do 2 to the power 5. And we can do 5 over 4 x cubed for the coefficient of the x cubed. Okay, so 8 to the 3 is 56. 2 to the power 5 is 32. 5 over 4 cubed is 125 over 64 x cubed, and so times 32 times 56 is 3500 x cubed.